Okay, so we've set this calculation up to find an amount of O2, which is one of the two reactants. We need to multiply everything across the top. 15.50 times 5 times, and let's do it all as one thing, 15.50 times 5 times 31.9988, and we get that number. Then we're going to divide as a separate operation this number on the bottom. So now I've got this number, I'm going to divide that by 44.0956, and I get 56.23933. You have to write out all those numbers there on the to show your work. 56.23933. We have grams left. We have O2 left. Now we have to round off correctly. So I'm going to look at all the measured and calculated numbers. The measured and calculated numbers include this one, and this one. Everything else up here is a counted number. We only want the measured or calculated numbers when we're trying to figure out what significant digits we want in the final answer. And so this one here has the least number of digits out of those. This one has 4, this one's 6, this one's 6, so we want 4 in the final answer to match this least number of, or least precise measured or calculated number. So we want the first 4 digits here, those are our significant digits. Underline what follows that and round off to the ones that are not underlined, and we get 56.24 grams of O2. Okay? All right, now that number is what we're going to use to try and figure out what the limiting reactant is. And the rule is, if this number that we calculated here for this species O2, if this number is larger than the amount we started with in the problem, okay, and it clearly is larger, that means this species O2 is the limiting reactant. If the amount you calculate of a species is larger than the amount you're given, that's the limiting reactant. If the amount you calculate of a species is less than the amount you're given, that's the excess reactant. That makes the other reactant the limiting reactant. Well, in this case, this is larger than the amount given, oxygen, than the amount given, so this must be the limiting reactant. Every mass-to-mass calculation that follows this starts with the given amount then of this limiting reactant. Everything we do after this is going to start with 25 grams of oxygen. Okay? All right. So we know now that O2 is the limiting reactant. I need to make sure I make that really, really clear. So I'm going to put up here O2 is the limiting reactant. Put it in the box so when the teacher goes and grades it, there's no question. All right? Now we want to start a new calculation to find the theoretical yield. Okay? And so now we're going to start with this given amount of limiting reactant. The given amount is 25 grams. So 25.00 grams. Have to keep all the zeros because you want to make sure that you're showing the precision of the measured amount. Significant digits depends on you keeping up with the precision of your measurements. All right, so we want to convert this to moles. And we've already calculated the molar mass down here. Don't have to do it again. I just use this equality statement here. Want to match units and species on the top of this fraction with what I'm going to put on the bottom of this fraction. So I'm going to put 31.9988 grams of O2 down here. And the other side of the equality statement, 1 mole of O2 goes on the top. Cancel units and species. Now I need a molar ratio step to go from one species to another. Remember, conversion units allow me to convert from one unit of measurement to another. Molar ratios is what you have to have. A molar ratio is what you have to convert from one species to another. So I'm going to take the moles of O2 from the balanced equation, 5, and put that on the bottom here. So I'm matching units and species here, but this number came from the balanced equation. But now I want to find the product I'm seeking. In this case, I'm seeking, in the problem, carbon dioxide. So what I want on the top here is moles of, not this, but the product over here. This is what we're yielding over here. The arrow here means yield. So we're going to put 3 moles of CO2 up here. Okay, cancel these units and this species. Now I need to convert this into grams. So I have to have a molar mass calculation for CO2. Carbon, we said, has an atomic mass of 12.0107. We only have one of those. Oxygen has an atomic mass of 15.9994. We have two of those in the CO2 formula. And luckily we've already multiplied that by 2 down here. We can just transfer that over in this case. Going to add those together. There are no empty slots over here, so we don't have to do any rounding off at the end of this. We're just going to add them together. Okay, we get 44.0095. So that's grams of CO2 equals 1 mole of CO2. Always molar mass is going to be equal to 1 mole of that species. So now I'm ready to build a molar mass conversion here. Match the units and species here with what I put on the bottom here. This side of the equality statement, 1 mole of CO2 matches it. So I put that on the bottom, 1 mole of CO2. And put the mass amount on the top. 44.0095 grams of CO2. Cancel units and species. And I'm ready to do this math. So I'm going to start with 25 times 3, then times 44.0095. Okay, I'm going to hit enter. Now I'm going to divide separately these things on the bottom. So I'm going to divide by 31.9988, hit enter, and then divide by 5 and hit enter. Okay, and I get 20. Well, the number I'm looking for is right here, 20 point something. I had a number, and I don't know what I got in there, but the answer to the problem we're looking for, no, yeah, it's 20.63022676. Okay, I've canceled all the units except grams and all the species except CO2. I want to round off again, looking at all the measured and calculated numbers, this one, and this one. The first one has the least digits. Round off the final answer to that same number of digits, 4. And we're going to get a rounded off answer of 20.63 grams of CO2. This then is the theoretical yield. You can just put TY, or you can spell out the words theoretical yield. That's the theoretical yield. Okay? All right. To calculate the percent yield is always the actual yield. That's the amount collected over the theoretical yield, and you multiply that number times 100, or that answer, that calculation, by 100. Our collected amount, our actual yield in the problem, is 12 grams. Okay? So 12 grams of carbon was collected, or carbon dioxide. So that actual yield goes over the theoretical yield we calculated here. And we take that answer, after we do that math, and multiply the answer times 100 to get the percent yield. Now before we do that, take note please that these units of measurement are going to cancel. Okay? In this case, both the units and the species cancel. But just as a kind of heads up for something we'll do in the second half of this unit, any percent should always be set up in a way that's going to cancel units. Percents are always unit-less answers. Okay? You don't have to know that really for this half of the unit, but you will. It may help you to know that for the next half of the unit. All right, so we're going to do the math now. So we have 12.00 divided by 20.63. Hit enter. Then multiply that number times 100. And there's our percent. All right, the full answer with all the numbers is 58.16771692. Okay, we're going to have to look at our original problem to figure out how many significant digits we want. These are the measured or calculated numbers. So I want both these have 4 significant digits, or 4 digits, so I want my final answer to have 4 digits. So after the first 4 digits we underline, we draw an arrow, and this is 58.17%. Okay? And that's percent yield of carbon dioxide. Okay, so that's the percent yield of carbon dioxide. Okay? Alright, so the problem asks for this one, A, asks for this one, B, and asks for this one, C. Okay? Huh? B is right here. Okay? Alright. It's a lot of math. We've been practicing this for, well, all this week, certainly. And we started setting up all this last week to get to this point. Okay? Alright. So I want you to then, I did ask you to exchange your papers, right? Alright, so we're going to go through and provide a grading key here. Let me stop this first.